So, welcome everyone. This is Ray Optics lecture number 2, and we were dealing with reflection in the previous class. We have seen the laws of reflection. The first law states that the incident ray, the reflected ray, and the normal lie in the same plane. Second law states that the angle of incidence and angle of reflection are equal. Did you get the sheet for optics? Okay, great. Now let us move ahead. Now in this chapter, in this particular topic, we'll be dealing with reflection. Now, as soon as I say the word reflection, the first thing that comes to your mind when you think about reflection is mirrors. Yes or no? Now, so in this particular class, we'll be dealing with reflection, and since we are dealing with reflection, we will be dealing with mirrors. Now, there are two types of mirror that we will come across. What are those two types of mirror that we'll come across? What are the two types of mirror that we will come across? Well, plane mirrors and spherical mirrors. Have you heard the term plane mirror and spherical mirror? You have heard the term plane mirror and spherical mirrors? No? You have not heard the term spherical mirrors, plane mirrors? Am I audible to you? You have not heard the term plane mirrors, spherical mirrors? Okay. Comes as a surprise to me, but I guess you have definitely heard the name, but may not be you are able to recollect it. You should be able to recollect it. It's not rocket science about plane mirrors and spherical mirrors. Okay. Everything takes time. And I'll show you plane mirrors and spherical mirrors now. And I hope that you can see this on your screens. Can you see it on your screens now? Well, the heading is real and virtual spaces. Don't go into the heading now. This type of mirror, oops. This type of mirrors are known as plane mirrors. As you can see, it's the mirror is flat. This is known as a plane mirror. The other two mirrors that you see, one is known as a convex mirror. The other one is known as a concave mirror. Which is the convex and which is the concave one? This is the concave one. Do we know this? Have you heard the term concave mirrors? And this is the convex mirror. This is the plane mirror. Mirrors are of two types. One is the plane mirror, which is flat. The other two are curved. As you can see, there is a curve. These two are collectively known as spherical mirrors. Do we understand this now? Okay. Now, every mirror divides the space into two regions. Now, this is how the sign convention was made previously. When I was of your age, we had two types of sign convention for mirror or lens. One was the Cartesian system, which we are using now. The other one was real and virtual space. It comes from there. But again, this is a concept that you must know. This side of the mirror, where the reflection takes place, this is the side which is reflecting, and the other one is the side that is polished or silver. Do you understand this? The reflecting side is known as the real space. The silver side is known as the virtual space. The reflecting side is known as real space. The other side is known as the virtual space. The side which is silvered is known as virtual. The side which is reflecting or real space is the space where the reflected ray exists. Wherever you see the reflected rays, that is the real phase or the real space. Virtual space is on the other side where the reflected rays do not exist. So this is what I mean by real and virtual space, is what I wanted to make you understand as a type of mirror, and every mirror divides the space into two places, two categories, or two halves. One is the real space where reflected ray exists. One is the virtual space where there is no reflected ray. Do we understand this? I'll give you a minute to note this down. I'll be back in a minute. Well, we have seen what is a real space and what is a virtual space. Now, this real space and virtual space was for mirrors, for lens. It is just defined in a different way. In terms of refracted, it is defined. Let us first see what is an object. An object. Remember, there are two things that we have to deal with here. One is the object and one is the image. Now, how is an object defined? Well, the way that an object is defined is it is decided by the incident rays only. To define the object, we need incident rays. How is the object defined by incident rays? If the incident rays are actually diverging, as you can see, this is a point object, and you can see incident rays are diverging. Incident rays are diverging. If the incident rays are diverging, the object is real object, which is the blue one. If the incident rays, the red one, you can see, they seem to be converging. They appear to be converging, then the object becomes a virtual object. So for an object to be real, incident rays must be actually diverging. For an object to be virtual, they must be appearing to converge. The blue and the red diagram very specifically tells us which object is real and which object is virtual. Now, can I ask you, what about this green rays or this green object? Is it a real object or is it a virtual object? One for real, two for virtual. Yes, it is a real object because rays are actually diverging. This is one way to understand whether an object is real or not. The other way to understand is the real world and the virtual world. Right now, we are actually living in two worlds. One is the real world, one is your web world, your social networking world, your virtual world. We are someone else in real and we are someone else in the virtual world. As you can see, this is the real world and this is the virtual world in terms of mirrors. Yes or no? So if an object exists in the real world, it is a real object. You can see this object is, the red object is in the virtual world, and that is why it is a virtual object. So this is another way of understanding whether an object is real or not. One way of understanding it, if the rays are diverging, it is a real object. If the rays are appearing to be converging, it is a virtual object. The other way is, if it exists in the real world, it is real. If it exists in the virtual world, it is virtual. Do we understand this? You'll have to note this down. I'll give you a minute. Well, now, we have understood what is an object. Now it's time for us to understand what is an image. Well, we said that object is defined by the incident ray. Then how is the image decided? Image is decided by the reflected ray in case of reflection, or the refracted ray in case of refraction. We're not dealing with refraction now, so we'll only see how it is in terms of reflected ray. Whatever we say for reflected ray, the same thing can be said for refracted ray. If the reflected or the refracted ray actually converge, they actually meet. Now look at this green ray, which is the reflected ray. Do you see this green ray, which is the reflected ray? They are actually meeting at this point. This point is I. Since they are actually meeting or actually converging, this image will be a real image. Do we understand this? The reflected ray are actually meeting, and therefore the image is real. What can you say about the object? I'm pointing to the object. This is the object. These are the incident rays, which are denoted by blue. What type of object is this? Is this a real object or is this a virtual object? 1 for real, 2 for virtual. 1. So this object is real, and the image it creates is also real. Do we understand this? Now look at the second diagram. The blue rays are the incident rays. Can you tell me what type of object is this? Is it a real object or is it a virtual object? 1 for real, 2 for virtual. The object is real, and as you can see, it is creating an image here. It is creating an image here. Is it a real image or it is a virtual image? The red one is the reflected ray. The red one is the reflected ray. They have only drawn one reflected ray. I could have drawn one more to make you understand. So what I do is I draw one more incident ray like this. The blue one. Blue one is the incident ray. This incident ray, according to laws of reflection, will be getting reflected, and it will be getting reflected like this. Now, if I extend these two rays, they do not actually meet. They are appearing to diverge from a point. They are appearing to diverge from a point. They are appearing to diverge from a point. They are not converging to a point. They are appearing to be diverging from a point. Such type of image is known as virtual image. Do we understand this? The other way of understanding this is very simple. The other way of understanding this is very simple. As you can see, this is my real world and this side is my virtual world. Do we understand this? This is my real world and this is my virtual world. As you can see, the object is on the real side. It is real. The image in Problem number 1 in diagram number 1 is on the real side, real image. In diagram number 2, it is on the virtual side, virtual image. You can understand in terms of real world or virtual world, but we don't use these terms anymore. So it is better to understand in terms of reflected ray. If the reflected rays are actually meeting, as in green rays, it is a real object, a real image. If they are not actually meeting, but appearing to meet, appearing to diverge, it is a virtual image. Do we understand this? I'll give you a minute to note this down. These are not given in your sheet, so you will have to note them down. Well, we have seen what is a real image, real object, virtual image, virtual object. Now, as you can see, the heading of this particular thing is plane mirrors, because first of all, we would be dealing with plane mirrors. Now, what is a plane mirror? A plane mirror is simply like this with this. What does this and this mean? We have one reflecting side, reflecting end. You can see this side is the reflecting side or polished side, and this one is the side which is silver. Do we understand this? We have also seen that you can call this world as the virtual world, and you can call this world as the real world. Yes or no? This is nothing but a plane mirror. Now, whenever we have a mirror, we use something, some sign conventions and some nomenclature. So let me first draw this. What is this? This is a point object. It looks like a point. Yes or no? Then there are incident rays like this. The ray is incident. Then the ray will be reflected. It will be reflected like this. I am showing it by the red line. The red line is the reflected line. Do we understand this? This red line can be extended like this. Then again, I take one more ray. This ray strikes the mirror here. And it will be reflected like this. Do we all understand this? Okay. This is the object, normally denoted by O. This is what I get as image. As you can see, I have drawn object with the blue color, incident ray with the blue color, so that you understand that blue is the incident thing. Object is defined by incident light, so it is blue colored. The image is defined by the red color. It is defined by the reflected rays. Yes or no? Do we understand this? Now you can very well see that this object is a real object. Yes or no? This object is a real object. But we talk about the image. Image is virtual. Now this is the type of image you will always get from a plane mirror. So what does a plane mirror do? We call this as characteristics. Characteristics of images. I hope everyone is noting it down. Formed by plane mirror. Is everyone noting it down, or am I the only one who is doing all the hard yards? Characteristics of image formed by the plane mirror. When I say characteristics, basically we are saying the properties sort of thing of a plane mirror. How does it form? What are the important points about the image formed by a plane mirror that we must understand? Here you can see the object is real, but the image is virtual. That means for a real object, it will create what image? It will create a virtual image. Do we understand this? A plane mirror will always create a virtual image of a real object. Yes or no? No or yes? Do we understand this? If I have a virtual object, what type of image it will form for a virtual object? One is real, two is virtual. What type of image it will form for a virtual object? And the answer is yes, sir. It will form a real image of a virtual object. How? Now, whatever I have drawn on the board is known as a ray diagram. Now, my simple and very simple question, and this question you would have done in standard 10. Can you draw ray diagram of image formed by a plane mirror when the object is virtual? I have drawn the ray diagram when the object is real and the image is virtual. Can you do the reverse of it? Can you draw a diagram where the object is virtual and the image is real? You should be able to do this. I'll give you 1 minute to do this. Object should be virtual and the image should be real. You have 1 minute to show me your talents. Oh. Okay. Then it's my humble duty to do it. How do I have a virtual object? Here is how you can have a virtual object. This is an incident ray coming and it appears to converge here. This object, my dear friends, is not an object from where incident rays are diverging. It is an object where incident rays are appearing to converge. Do we understand this? The rays after reflection will go like this. I will make one more ray for you, and the other ray for you will go like this, coming from far off, probably. After a reflection, the red one, it will come like this. This will be the eye, the image that is formed. Now you can very well understand, my dear friends, what type of object is this? What type of object is this? The blue one. It is a virtual object. Yes or no? It is on the virtual side. And what type of image it is? This is a real image. Do we understand this? Can I have some raised hands that we understand this, sir? Well done. Now is the time that you will draw it. And I'll give you a minute to do it. Let's move on and see what is next. What is next is a very basic fact. You must have read this. Now, if I call the distance of this object from the mirror as u, have you heard this term u? U was velocity, initial velocity. Right now, u means something else. U means the distance of the object from the mirror. Do we understand this? And I call this distance as v. V is the distance of image from the mirror. Here, this distance is v and this distance is u. Do we understand this? U is equal to v numerically. That means distance of object from the mirror is same as distance of image from the mirror. Do we understand this? The object distance is known as u, the image distance is known as v. Distance of the object from the mirror will be same as the distance of the image from the mirror. Do we understand this? I'll give you time to note it down. U is equal to v. Let's move ahead. Up till now, the object was a point object. It was just a point. If I talk about objects which have height or which are known as extended objects, I hope you understand. I will call this object as an extended object. It has a height here. Now this object, let us assume that this is my plane mirror. This object, this is the plane mirror. Anyone can see my plane mirror and my object. Now this object is placed like this in front of this plane mirror. This will be known as an extended object. Now extended object has a height. Do we see this height of this extended object? Right? So if I have an extended object, point number 4 arrives, and to arrive at point number 4, I will have to take you back to my sheet. And where is the sheet? Sheet is here. Where are you? Sheet is here. Okay. So if I take you to extended objects, the height of the object, remember, to understand plane mirror, you can easily understand it by imagining yourself in front of a plane mirror. Most of the mirror that you use to see your face in are plane mirrors. The height of the object, in that case, object is yourself. The height of the object and the height of the image. What is the relation between the height of the object and height of the image? It's very easy to understand that the height of the object is same as the height of the image. Do we understand this? Height of the object is same as the height of the image. Whenever you see yourself in a plane mirror, the height of the image that you see is exactly same as the height of the object, which is you. Do we understand this? Now remember, and we will see in the coming classes, and you will be able to understand. Here I have written the distance of the object is same as the distance of the image, or u is equal to v. And in point number 4, I have written height of the object is same as height of the image. When we go ahead, we will understand that these two things are very closely related to each other. That means height of the object is somehow related to the distance of the object. Height of the image will be somehow related to the distance of the image. And it is very easy to see. When you are very close to the mirror, you will appear very tall. Yes or no? But when you go further ahead, you will see that the image has gone smaller in size. But even in that case, the height of the object and the height of the image is same. Do we understand this? When you look at a far object, it appears smaller, but when you go closer, oh, it's appearing bigger. Height of the object and height of the image are related to the distance of the object and distance of the image by a formula which is known as magnification formula. What is the magnification formula? For any object which creates an image or it is refracted, we have a magnification formula, and this magnification formula, or M, is known as magnification. M is known as magnification. And this magnification in all the cases is equal to height of the image divided by the height of the object. Do we understand this? This is very easy to see. How much is the image magnified? If you look at the magnifying glass, very small objects appear big. Magnification is very large. Height of the image is very large compared to the height of the object. Do we understand this? What is magnification? In short, magnification is the ratio of the height of the object to the height of the, height of the image to the height of the object. Do we understand this? Now, in this case, since both are same, the value of magnification would be equal to 1. Do we understand this? These are some of the characteristics. I've written 5 characteristics of image formed by a plane mirror. If the object is real, the image is virtual. If the object is virtual, the image is real. The distance of the object is same as the distance of the image. The height of the object is same as the height of the image. Or the magnification for the plane mirror is equal to 1. Have we noted this down? You want me to wait? I'll give you 1 minute to note these points down. Then we will move on to the next points. That takes us to the next point, which is known as lateral inversion. Now, what do you mean by lateral inversion? We have seen it. There's no point of me telling you this. Right hand becomes left hand on the image. It gets laterally reversed. If you write the letter P, it will look like the reverse of letter P. That is known as lateral inversion. If you have a symbol like this, it will look like this. If you have your own hand like this, it will look like this. Yes or no? That is point number 6. The image formed by a plane mirror suffers lateral inversion. Left is turned into right and vice versa. Do we understand this? Please note it down. Note down the heading. Note down lateral inversion. Well, if you have noted this down, then these are the type of questions that you may encounter. What does the clock read? So looking at the mirror image of what you see of the clock, and there are no numbers written there, only dot, 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 12 dots are there. And then you see a mirror image of a clock. What is the actual time? I've seen questions of this nature coming here. Now, there are 3 types of questions that can be given. Question number A, question number B, question number C, or 1 to 3. Question number 1, we only have hours, like it is 6 p.m. or 5 p.m. or 4 p.m. The minute is not there because the minute is 0, second is 0. In case number 2, we have hour, as well as minute. 5:15, 5:20, 5:30, that is the time. In the third case, you have seconds also, 5, 15, 20 seconds. If the mirror clock is showing 5 p.m., 12 minutes, 20 seconds, what is the actual time? Do we understand the 3 types of variations? In first case, it is exact 1 o'clock or 2 o'clock or 3 o'clock. In second case, it is time with minutes. In third case, it is time in minutes as well as in seconds. Do we understand this? So, if it is showing A as hour, the image time would be 12 minus h or vice versa. So basically, if it is 10 o'clock on the clock, it is 10 o'clock on the clock, the image will show 12 minus 10, that is 2 o'clock. Do we understand this? If the actual time is 10 o'clock, the image will show 2 o'clock. Do we understand this? 12 minus the time will give you the correct time, or 12 minus time will give you the clock wala time. For example, if the clock is showing 10 o'clock, the image will show 12 minus 10, that is 2 o'clock. Do we understand this? Similarly, if the clock is showing, let us say 10:15, so it has an AM as well as the BM. AH means hour wala hand is also there and minute wala hand is also there. Then the correct time or the image time would be 11:60. So 11 hours 60 minutes may say you will have to subtract the reading. For example, this is 10:15 is the original time. The image will show 11 minus 11:60. You have to subtract 10:15 from 11:60, and the time that you will get would be 1:45, and the image will show 1:45. This is what that is illustrated over here. Do we understand this? And the actual clock is showing 10:15, the image will show, when the actual clock is showing 10:15, the image will show 1:45. Do we understand this? If you also add seconds onto this, so the formula becomes 11:59 minutes 60 seconds minus the clock time. What do you mean by this? If the clock is showing 09, 42 and 30 seconds, 33 seconds, this is the actual time of the clock. What will the image show? I will give you a question. I hope you have written this formula. Have you written this formula? Yes or no? Which formula? I will again take out everything and just highlight the formula that you will have to write. If the object time is only in hours, the image time will be 12 minus hours. The red, the blue one, the yellow one. If the object time is in hours and minutes, image time will be 11:60 minus that time. If the object time is in hours, minutes and seconds, the image time would be 11:59:60 minus that time. Do we understand this? The yellow, blue and the green one. I'll give you a minute to note it down. Have you noted it down? Then I give you this small question which I am now highlighting in green. If the actual time is 11:42:33, what would be the time on the image? Or it could be ulta. If the image time is 9:42:33, what is the actual time? Question is same. Whether do you call this green wala time as the clock time? I will ask you the image time. If you call this as the image time, I will ask you the clock time. Do we understand this? Get me the answer. Yes, so there has given me an answer. You just subtract 9:42:33 from 11:59 and 60. That would be your answer. So I think the answer would be, I'm not very good with addition and subtraction. I think the answer would be 2, 17 and 27. 2, 17 and 27, that would be the time that would be shown on the image. Do we understand this? It's very simple. You can expect a question to come on here. Now let us move on to the other topics here. And we are only concentrating on the type of questions that can come. What is the next type of question that can come? You can write the heading as number of images formed by two plane mirrors. So that will be your heading. Number of images formed by two plane mirrors. As you can see, there are two plane mirrors here, 1 and 2. Do you see this? Yes or no? Now these two are inclined at an angle of theta. Do we see this? Depending on how much is this theta, you can have different number of images. For example, case number A, you will have to remember this, no point of understanding it. If 360 divided by theta, this is what we have to find out everywhere, 360 divided by theta. If 360 divided by theta is even, for example, if theta is 60 degrees, if theta is 60 degrees, then 360 divided by 60 would be 6. 360 divided by 60 would be 6. In that case, the number of images will be this number subtracted. Subtract 1 from this number. So the total number of images in this case would be 5. Do we understand this? If I divide 360 by 60 and I get an even number, the number of images will be 1 less than that even number. If that even number is 2, images will be 1. If that even number is 4, images would be 3. If that even number is 6, images would be 5, and so on. Do we understand this? The second case is when this is an odd number, for example, 1, 3, 5, 7, and so on. Then there will be two cases. When the object is not on the bisector, when I say bisector, I mean the angle bisector, then the number of images is same as m. When the object is on the bisector, the number of images is n minus 1. For example, if 360 divided by theta is 3, if it is placed on the bisector, the number of images would be 2. If it is not placed on the bisector, number of images would be 3. Do we understand this? If 360 divided by theta is a fraction, for example, 7.3 or 6.7, if it is a fraction like this, then the number of image will be the integral part. When I say integral part, I only take this number. The number of images in that case, if it is coming as 7.3, the number of images will be 7. If it is coming as 6.7, the number of images would be 6. Do we understand this? You'll have to draw this diagram in the sheet. Draw the perpendicular, draw the bisector, and write all the 4 cases. Case number 1, if it is even, number of images is 1 less. If it is odd, in odd we have 2 cases. If it is not on the if it on the bisector, it is 1 less. If it is not on the bisector, it is same as the integer we have got. If it is a fractional number, then the number of images would be the integral part. I will give you 2 minutes to note it down. I hope you have noted this down. And here is an example, the table. The angle theta is 0. Number of images are infinite. If it is 30, 360 divided by 30 is 12. It is an even number. So the number of images will remain 11. If it is 45, it is again even. If it is 60, it is again even. If it is 72, it is again not even but odd. If it is odd, if it is placed symmetrically, the number of images is same. If it is not placed symmetrically, the number of images is same. If it is placed symmetrically, the number of images is 1 less. If it is 4.8, then the number of images will be 4. In case of 90, it is an even number, so the number of images is always 3, and so on. Do we understand this? How we have achieved this? So you can just see, have a look at this table and understand what we had discussed. Is this table clear to everyone? Have you noted it down? Now again, as I've told you, this chapter is all about remembering the various concepts. One more concept that you will have to remember is deviation produced by a single mirror. Now, what do I mean by when I say by deviation? As you can see, this is the reflected ray, the red one, and this is the incident ray, the blue one. If I extend the incident ray will go like this. The angle between the incident ray, please mark my words, the angle between the incident ray, the green one, and the reflected ray, blue one, in case delta, this delta is the angle between incident and reflected ray. This angle is known as angle of deviation, and this angle of deviation in case of a single mirror is 180 minus 2i. It is very easy to derive this. We are not doing this because we have to save time. So deviation for a single mirror is always equal to 180 minus 2i. Do we understand this? I'll give you a minute to note this down with the diagram. Well, we move on to the next heading, and this is the total deviation produced by a combination of two plane mirrors. Instead of one mirror, I have two mirrors which are inclined at an angle of theta. So angle between these two mirrors is theta. Do we see this? Angle between these two mirrors is theta. Then what is the deviation produced? You just have to remember that deviation produced is 360 minus theta. 360 minus 2 theta. The only thing that has changed from the previous question is instead of 180, I have 360. Instead of 180, I have 360, and I will show it to you. I will highlight it. Instead of 180, I have 360 here. In place of 2i, I have 2 theta. If you can remember one, you should be able to remember the other one. Whichever you feel comfortable, you can remember it. Give you a minute to note this down. The next point is this one. What is the minimum length or height of a mirror that you must require to see your complete image? Obviously, if the mirror is too big, you will be able to see your image. But if you start to decrease the height of the mirror, at some point, you will stop seeing your image, your full image. So the minimum height of the minimum length of the mirror to see your full image is always equal to half of the height of the person, and you will remember it in that way, nothing else. Do we understand this? Half the height of the person is the minimum length or height required for a person to see his full image in the mirror? Please note it down. Let us move ahead. And what is the next thing? Remember, we have already noted down that the minimum length of the mirror we require is half of the person. Now remember this. This result does not depend on the position of eye. Where is your eye does not depend. Some people may have eyes on the higher side or some people may have eyes on the lower side. It does not depend on the distance of the person. You cannot say, sir, if I go very far, I will be able to see myself. No, beta. You need a minimum height of the mirror to see yourself, or minimum length of the mirror. And that minimum length of the mirror is half the height of the person. Do we understand this? Please note these 2 points as well. Let's move ahead and we come to this point. If you are standing, if a person is standing, as you can see at this point, the person is standing and he wants to have a look at the complete wall which is behind him. How much is the minimum length of the mirror to see this complete wall? Remember, he is standing midway between the two. So this distance and this distance D is same. In that case, how much height of the mirror he needs? Remember, the height of the mirror he needs to see a wall that is behind him is 1/3 the height of the wall. You may not have to draw this diagram, but you will have to remember this result. So please write this result in the notebook. I'll give you 2 minutes to note it down. Here we go with some questions. This is the first one. Let's see who gives me the answer. When light is reflected from a mirror, a change will occur in its which quantity? Phase, frequency, wavelength, speed. We discussed this yesterday. Can you give me the answer today? What will change when the light is reflected from a mirror? A, B, C, D, 1, 2, 3, 4, and the answer is no one knows the answer. 1, 2, 3, 4. What is the answer? What changes? Remember, whenever light is reflected, frequency never changes. It is in the same medium. Speed never changes. Wavelength never changes. V is equal to F lambda. The only thing that changes is its phase. Remember, when it is getting reflected from a denser medium, the phase changes. If it is getting reflected from a rarer medium, the phase remains same. A mirror is polished from the other end. It will always undergo a phase change. Do we understand this? Yes, sir, or no, sir? Then, sir, I will give you a question to redeem yourself, sir. And this is the question with which you can redeem yourself. Question number 4 from your sheet. A ray is incident at an angle of 38 degrees to the mirror. The angle between the normal and the reflected ray is how much? Can I have the answer, please? And I have the answer from Kajal, which is 38, which is wrong. The ray is incident at an angle of 38 degrees to the mirror. You have not read the question carefully, beta. If this is my mirror, this is the normal, this is the incident ray. He is telling us that this angle is 38. This will be the reflected ray. This angle would be 52, 90 minus 38. Angle of incidence and angle of reflection is same. He's asking about normal and reflected ray. He's asking about this angle. This angle would be 52. Do we understand this? So, if you don't read the question carefully, what have I done? Done something wrong here. But I will correct myself. Don't worry. Will correct my mistake. And I hope my mistake is corrected. Do we understand what we have done? Is everyone there with me, or I have lost you somewhere? Again, one question to redeem yourself. Here it comes. What shows the time as 3:25? What will be the time that appears when seen through a plane mirror? And the answer is, my dear friends, A, B, C, D, 1, 2, 3, 4. And the answer in this case is definitely 1, 8:35. Do we understand this? Can I have some raise hand that we understand this? Okay, pretty good. Let me have this one as the next question. I want you to be very thorough with this chapter so that we have no doubts remaining in this chapter. Here is the question and what is the answer? The frequency of an incident ray is 3 into 10 to the power h. What will the frequency after reflection? And the answer is 2. It will remain same. Don't forget it ever in your life. Ever in your life. Ever in your lives. And here comes the next one. An object is placed between two plane mirrors at an angle of 60 degrees with each other. What is the number of images that you shall see? You shall see, you shall see, you shall see. And the answer is C. We first divide 360 by 60 and we get as 6. 6 is an even number. So the number of images will be 1 less than the even number and the answer would be 5. Do we understand this, my bacha? The next one. The next one comes. Mark the correct options. Question number 8. Section A. And the answer is I can't see it in light. And the answer is 2 if the final rays are converging, we have a real image. Do we understand this, or it has gone above our head saying bye bye? Bye bye, bye bye, bye bye. Here I go, bye bye. Two more questions and we will wrap this class up of plane mirrors, and this one, my dear friends. A man of 160 centimeter is standing in front of a plane mirror. His eyes are a height of 150 centimeter. What is the minimum height of the or length of the mirror that he could see his full image? Full image. Question number 9. And the answer is don't have an answer. Is that the answer? No. That cannot be the answer. The answer is 80. Does not depend on the height of the eyes. It only depends on the height of the person himself, and is always half of this height. Yes or no? No or yes? One more. One more. Which of the following letters do not suffer lateral inversion? Oh. Let's see. Who gives me this one? I can't see you have fingers. And the answer is 2. Hawks. That is correct. My dear friend, it is Hawks. And now comes, I always end up this class with something that if you can give me an answer, I would be really happy about. Here comes question number 12, and I have not told you anything about the velocity of the object. Can you give me the answer for this one? Applying some common sense. Applying some common sense, can you give me the answer for question number 12? If you don't know how to do this, well, let's see who gives me the answer. If an object approaches a plane mirror with a velocity v, when with what speed the image will approach the object, and the answer is 2v. Do you understand this? Well, if you understand this, congratulations. We are almost done with the type of question that can come on plane mirror. So we will call it a day, and I leave the rest of the question for you. The question is too lengthy, and if it requires a lot of diagram, you may skip it because you may not be having enough time for it to solve, for you to solve it. These are the type of questions, if they come, you should be attempting it. So I'll end my class today here on this note. You have the sheet with you. Solve as many questions as possible. There are a lot of very simple and good questions, and I can assure you that the question that is going to come in the exam will be from the sheet itself. On that note, take care. Have a nice day. Bye-bye.